Okay, in this video, we are going to be taking a look at the makefile. So right away, take a look at what we're going to end up with this makefile. It looks pretty daunting. It looks pretty big, but it does some pretty good stuff. If you were very keen-eyed in the last video, you would have seen a mistake that I made in the code. Let's see, where was it? In the game. Right down here, I misspelled default. Now, when I went to run this, it works, right? Works a treat. But if I were to use my make file, this is going to compile whatever's in the source directory. So if I just say make, it fails. And it tells me right away, I have something wrong here. This label, default, is not right. So right away, I pick up an error that I didn't even see and that didn't even show in my just standard compiling of the program. So let's fix that right away. So you're going to want to fix that on yours as well. But let's talk about this makefile. So we're going to build this up. So I'm not just going to walk through it. We're going to actually build this piece by piece. Yeah. So I am going to delete this makefile and then we're going to make it. So if you already have you already have a makefile as well, so you probably want to do the same to delete it. So it's in the top level directory. And it's going to be called makefile, and it's got a capital M. So and this makefile is used by the make program. So you're going to need make installed as well. And I'm specifically using GNU make, which if you're on Windows and you're using make, you're probably using GNU make. If you're on OS X, again, probably GNU make. The makefile we're going to make is not POSIX compliant. It's using some specific add-ons that are GNU make, but GNU make is the most common version of make, so we're going to stick with GNU make. So right away, a makefile can just literally, it's just there to automate our task of building our code. So it's very basically, it's going to have some rules in it. So let's start by just making a rule. Let's put in the what we've been compiling with, which is this string right here. So is it going to let me select it? Yeah, I think I can just yank it. So this is basically how we've been building it. So if we think about this as a recipe, there's something called rules in the makefile. We have a target, we have a prerequisite, and we have a recipe. So let's make a rule for this makefile. See if we can do that. Let's call it yellow snow. And let's give it no prerequisites. And we're going to use a tab, and we're going to just try to make this our recipe. I actually don't know if this is going to work. I've never tried this. Let's find out. Oh. I'm going to delete, manually delete the yellow snow binary that I've already compiled, because it's basically telling me, hey, yellow snow is already there. I don't need to do anything. So I'm just going to manually delete that real quick. And now I'm going to run make. And it created it. So what we have here, this is a rule. So the first part here, yellow snow, that's our target. That's what we want to happen. We want this file to be made. If we go after this colon here, we can put prerequisites let's say things need to be built before this yellow snow can be built. If we had some other files that needed to be built first, we could put those there. So before it even tries to run the recipe of this rule, it will go and do the recipes of those rules, or it'll build the targets of those rules. So we didn't put any prerequisites because basically we're just telling it to build the whole thing right here. Okay, so this is the recipe here, and we're just putting it all in here. So let's start making this a little bit more interesting. So let's call our target, let's call it target, because that's what we want to build, right? And I'm going to use some tabs to kind of line these up. We'll call it yellow snow. And then right away we can change this to be our target. So in a makefile, we're going to use these, the $ and the parentheses. This expands the variable. So this is the variable that we're creating. This $ and parentheses is expanding our variable. So whatever this thing contains is going to be expanded into right here. So yellow snow is gonna be right there. So we've set a variable now, and we have our target. Let's see if that works. I'm gonna delete it again. And still works. Okay. So that's pretty cool. But what about you might not want, excuse me, you might not want to be running GCC. You might be wanting to run CLang, or you might want to choose which one. So let's abstract this CCC. Sorry, just as C compiler. Let's extract this out into a variable as well. And we can actually put GCC here or CLang, or we could do something really fancy. We could put a question mark here. And this is going to say, we can accept an input, but if we don't get one, we're going to use GCC as the default. So let's try that real quick, and we'll put our variable here. Okay, so we know we're in C, and we got that going on. So now let's try, I'm going to delete it again, and now let's try to force it to use CLang. So I could say cc equals CLang, because I have both installed. And then I'm just going to run make. Don't worry about what you see here. This is my, I'm using fish, and fish does an autocomplete for me. But I'm not accepting that. So that's kind of a suggestion, but I'm not using it. I'm just using the make word. And there, we just built it again with CLang instead of GCC this time. So that's pretty good. We have basically, we have some variables. We have these rules here, but we can make this more generic. I want this makefile, for one, to do more work for me, but also I don't want to be specifying folders, file names, and I want more work to happen. I want to be able to give it more flags for the C flags for the library for everything. I want it to be doing more work for me, but I also don't want to have to be writing it every time. There is another command too that I want to talk about first real quick. If you're on Linux, you're kind of in a really good development environment where it's just in your path a lot of times. But if you're on Windows, maybe you shouldn't be on Windows, but if you are on Windows and you made bad choices, you're going to want to, you need to specify where your libraries are, where your header files, and all that stuff. So there is kind of some tools that help find those things. Package config is one. So package config. If I was to run package config and I use this switch called cflags and then SDL2, and it's a bit funny on this one. It's a lowercase SDL2. And there's no -L in front of it. The -L stands for lib. This is specifically for a package config command. You will need this installed in your system, but it should be if you have a build environment. This should tell us what are the the C flags for running this. So let's do that. Am I not? Sorry. There we go. So it's actually telling me where to find this. So if yours is in a different location, but package config can find it, it's going to populate where that is for GCC or CLang. And it also works for the libs. For me, it's just saying, hey, it's in your standard path or whatever. So we can use these tools as well, and we can mix them in for helping our compiler to find our header file, our include files, header files, and our libraries. So these are two commands that we're going to add in as well. So let's talk about C flags. So we got this CC is the compiler. We can set another variable here. We'll call it C flags. And I want to tell GCC to at least, or CLang, to that my code is at least C99. I'm not writing C89 code. I'm writing C99 code. I'm not really doing anything from C11 or C17, but I'm definitely using C99 code. There's a couple things in there that are a little bit more modern. So I want to tell the compiler that I'm doing that. So I can add that switch in. This would be equals C99. Okay. And what would happen is I can just put this normally in when I'm using GCC or whatever. It would be right after. So if this is GCC, I could put minus and I could put the C flag in right here. So let's just do that. So let's put in C flags. Okay. So now this guy will be here, but we could populate these more out. We could put much more stuff in. And let's also add in our to C flags, I'm going to add in the package config. And the way I'm going to do this is you can do this with backticks, okay? But because I'm going to give it a shell command, so so this command we're doing right here, this is not part of make. So this is just a shell command, a console command, right? It's a little utility that helps us. It sends back information. These two things that it sent back. So if you want to do that from inside of a make file, you could put these backticks, but doesn't work on every system. I think it works on Linux. I don't know if it works on Windows. I'm not quite sure. So the other thing that you can do is we could use this, and then we could say shell, right? And then we can do our package. And we can put in our C flags here. And we'll put in the SDL. Sorry, it's not minus. And it's really strange on this one because the SDL is lowercase. I'm not actually sure off the top of my head why that is. But we could put the other ones in too, all the stuff that we want. It doesn't matter if these are going to be later on, but we can just put them in now just so you can see. SDL2 image, SDL2 TTF, SDL2, sorry, mixer. Now these are all capitals. These are all SDL2 capitals, but SDL2 by itself is not. And that is just specific to this, the way package config works. So it is package config. Okay. So that gives us, so these are white space, like each thing. Imagine these are just in the command line. So if I was writing GCC in the command line, then I could put a space and then minus std equals C99 and then a space. And I would want this to return. I don't want this kind of in line. I want it to be evaluated and whatever is coming back returned. And we'll see what this expands to real quick. So that's what it expands to. So that's actually what we want there. we want this command to expand to this. So that's going to do that right now. And we can also do the same with the libs, which is going to almost look the exact same. Do ld libs and we'll say equals, and I'm going to do the same thing that we did before, but in the front I need the shell. So this shell is actually a function of GNU make. So this is part of GNU make. The package config is not, but this is telling GNU make, hey, we want to run a shell command. So this is kind of like a function that's taking the rest of this stuff in and doing what it would do in a shell. So the other thing we can do here is right here. Now you would expect that we can put target down here, but we don't need to. If we want to access what the target is, we can actually just use a $sign and an is it not ampersand and an at symbol? I forgot what it's called. Okay, so this guy right here, it says whatever this target is, that's this guy. So we can use that. Now we have this down here. This is going to be replaced with our ld lib, so we can do that. Right there. Now we're starting to get a little bit more interesting. Let's just compile this real quick. Make sure no mistakes were made. I got to remove manually the I don't even know if we have yellow snow there. I don't think we have it there. Okay. Oh, hello. So I think I've made a mistake here. Package config. Oh, yeah, I did. Okay, so this command down here for libs needs to be libs. So it wasn't able to link the libraries it needed. It was getting the so package config runs two different things. I had the C flags in there, which will give it where the header files are, but this one needs to tell me what the libs are that it needs to look for. Okay, and that compiled. And you can see in the code here, we got cc minus std, and you see all the includes from the one command. And then you see the source files here, and then you see the target, and then you see these are from the package config lib. Okay, so now let's talk about. So we can actually have so this is called a rule, and we can actually usually rules have they're building a real file, but we can have what's called phony rules, and they're kind of like we want the same kind of functionality as a rule, but we're not actually building a specific target. Yeah, or we're building something that is defined somewhere else. So phony, and I'm just going to list off what these are. Let's say all. We could do clean. We could do run. We could do rebuild. I'm just, these don't have to be, but clean is good, run is good, just for ease of use. And what would these look like? So what we're going to do is we're actually going to build one of these. So let's say all. All, as a rule, it's building all, but it's a phony target. And it has a prerequisite, and the prerequisite is target. It's just saying, hey, build everything. So it's not really interesting. It's not really doing anything, but you can kind of see this is considered a phony rule. Okay, so now if we go down, we could build, say, if we want to clean. So clean is it's a bit of a hard one because I'm going to show how to work on the non-Windows systems, but later we're going to swing back to Windows systems. So let's make a variable for clean. Oh, let's just do it real quick. We'll just make it clean. So clean, and it doesn't have a prerequisite, so that's blank, but it's going to do something. So what do we want it to do? We want it to delete the target. So we can say I'm gonna use this. This is an internal. This is an internal. I think it's replaced with rm minus f or something like that. But basically, it's a it's rm. It's internal to makefile. It's a already variable already for us, and I'm going to tell it to remove the target. Okay, so this is not really building anything. That's why it's phony. It's a clean, and its recipe is, hey, delete the target. So what about run? Run is going to have a prerequisite. So if we do run has a prerequisite, which is target or all. So we could do that, or we could say target. Yeah, and the we in the recipe, we're going to tell it to run something, and what we're going to do is this, and we're going to do this. Sorry, this. Now this guy is the first prerequisite. So here's our rule. Our rule is target is run, which is a phony target. Our prerequisite is target. Okay, so target needs to be built first before run can run. So if it sees run, it says, hey, go do this thing first. This is up here. It's going to go do this. Then it's going to come back to here, and it says, okay, now I'm going to do forward period forward, which is the way you run something in Linux and Unix. I do not know about Windows. Sorry about that. But the $sign for variable, and then this greater than sign, I think it is, eating to the right, Pac-Man going to the right. This guy is a placeholder for the first prerequisite. So if I had a whole chain of prerequisites here, 1, 2, 3, 4, 5, 6, whatever, the very first one on the list is what this is. So I'm saying, hey, run whatever the name of the first prerequisite is, which is the target. So we've made some interesting here. All doesn't really do anything. Clean deletes the thing that we just made. Run makes sure it's built and then runs it too. And we could do a rebuild. And the rebuild would look like this. And basically it's just prerequisites, which is going to be clean and all. And it has no recipe. Its rebuild is saying, hey, run clean and then run all. So let's try some of these out. So now we can say make, everything's up to date. We can say make rebuild. Now you'll notice it deleted it and then rebuilt it. We could say make run. It didn't even build it. Because again, here's another thing about the makefile. If it's already built and everything is up to date, it timestamps. So it's actually timestamping these things. Where is it? This target is timestamped. If it is still of the same, nothing has been updated. It's not going to rebuild it again. So it's basically saying it's already built. I don't need to rebuild it. When we have the prerequisites later for when we make this build a little bit more complicated, it'll timestamp the source files. Yeah, these source files are still timestamped, I think. Let's just check that real quick. So let's do a make. Okay, it's up to date. Now let's go in here. Oh, sorry. Let's go to main and let's change something. Now, we'll see if it's going to rebuild it or if it's going to say it's already up to date. Okay, so it does say it's already up to date. So later on when we have prerequisites with where the source and header files are prerequisites, it's going to timestamp those. So it's not doing it here. It's just saying the file's there because we don't have any. Let's delete this real quick and go back. So here on our target, we have no prerequisites. So when it does have prerequisites, it's going to check those. And if those haven't been changed since it's built last time, it's gonna say it's all up to date. But even if one of them has been changed, the source or the header file, that part of it will be rebuilt. So we're actually going to be building these all separately. So since we have 3 source files and 3 header files, we're going to have 3 object files that are built. And if I change one of them, that one object file will be rebuilt, and then the final executable will be remade with that new object file that has been changed. So this is kind of, you see these rules and you see rules and you see prerequisite, not on this one, sorry, rules, prerequisites, rules, recipes. This is a recipe down here. We're seeing variables. We have this guy here, which is a placeholder for the target. We have this guy here, the greater sign to the right, is a placeholder for the first prerequisite. There will be the caret symbol, which will be a placeholder. It's a special for all the prerequisites, not just the first one. Okay, so let's start making it more interesting. What we want to do is we can build these piece by piece. So let's say we want to see the so we've been building all 3 of these source files all at one time and right away outputting them, but we don't need to do this. What we could do is we can do something like this. We can say main. We would tell it we only want to build the sort. We only want to compile it to an object file. So we'll use the -c, and output will be main.o. Yeah. And what this is going to do is in the top level here, it's going to make a main.o file. We won't be able to do anything with it. Okay. And then if we do this on all of them, okay. So we have main, game, and initialize. Then what we need to do is we can say main.o, game.o. And then now we're going to output it to our actual file, which is yellow. And we still need to run our linker. For this one, it's just the SDL2. So this will take the object files that we compiled separately, and it will compile them into the final binary. Oh, should be O minus O, sorry. Okay, so the reason why we would want to do this is if we have a whole bunch of different files we're building, or we're building a lot often, if nothing has been changed in those headers or source files, we don't need to rebuild those. And if we have an error in one, the other ones that built are already built. We don't need to do the work twice. So this idea of building them, the object files, and then bringing it together is kind of the way most make files are going to be going. So we're not going to be doing the all-in-one. We're going to be building them separately, and it's going to be a little bit fancy because we're going to build them in a build directory. So let's do that. So I do want a build directory. I'm missing all this Windows stuff that I'm going to be dealing with in a minute. So build directory, and I'm going to put it in .build. That's kind of like a hidden file, unless you can see hidden files. You see it over here actually, .build. That was from our old, the original make that we ran in the earlier in the video to fix that bug. It's actually here, and let's see if we can go inside of it. Oh, there's nothing in it. It's just empty. Okay. So so we have the build directory here. We're going to put a rule to build that, to to make sure that that exists basically. So we're going to do the build, and its rule is, or it's not going to have a prerequisite, but it is going to have a recipe, which is make dir, which is a function of this make, the kind of make file language. Even though this make directory is a shell thing, this is actually part of the make file. Just like this shell command up here, make file is a part of it. And we're just going to build, sorry, this should have been a $sign. We're going to do the build directory. So it's saying, hey, make sure that this exists. This is going to be a target. So later on, we can use this as a prerequisite, and then it's going to build it for us. And then we're going to say how to build object files. So basically, we're going to make these object files. Okay, so we're going to give it a rule on how to build object files. And this one's going to be a little bit more different looking. So this one is going to be the build directory, and inside of the build directory, we're going to have this %, and O. So it's going to be for anything that is a variable that expands to anything that is going to represent this O. Let's set our source directory as well. So source directory. And that's just going to equal source, what we've been working in. So our prerequisites for building an object file is going to be the source file and the header file of the same name, right? So just like what we did in the command line, I don't know why I was there. So just like what we were doing here, where we're building objects files separately, this is kind of what we're going to be doing. It's going to say, hey, to build this object file, we need a header and a source. We're going to check both of them, and we're going to do a recipe like this. That's kind of the thing that we're going to be doing. So this is kind of a weird one. We're going to keep going with it for a little bit. And so this one's going to have 3 prerequisites, but only one of them is going to be kind of watched for times, or 2 of them are going to be watched for timestamps. So we're going to be looking at source directory, and of the same name, but a .c file, and also the, oh, sorry, I missed the parentheses here, and the source directory, and the %sign.h, both of these. But I also want, as a prerequisite, I want to the build directory, because I can't put this in a build directory if the build directory doesn't exist. So these 2 are prerequisites, but they're going to be time stamped. That means if the C file ever changes or the H file ever changes, this guy's going to get rebuilt. But if these are still the same and this guy already exists, then it's going to say, I don't need to rebuild you. Now the build directory, I don't want this to rebuild if the build directory has ever changed. I just want the build directory to exist. I don't care if it's changed. So I'm putting up this pipe here, and this is basically saying to ignore that. It's still a prerequisite, but these two are checked for the kind of timestamp check, and this other one is not. But it is a prerequisite. So that is going to say, to build this object file, I need this source file in the source directory. I need this header file in the source directory, and this is going to expand into the name that is going to be here. And I also need the build directory. And now to the recipe to build this object file is going to be the CC. It's going to be the C flags. It's going to be the -C like we did when we were building just the object file. It's -C. And it's going to be the name of the first prerequisite. So we have these prerequisite, but this build command, you remember it was GCC, the flag, which we didn't actually put any. So it was GCC -C, and then it was the source file, which is here. So this is the first prerequisite. So since we want the first prerequisite, we're going to do this. That's the greater than sign to the right. That says this guy. So this guy right here is going to be here now. And the output is going to be this name right here, which is the @ symbol that we did before. Okay, this is like one of the most complicated bits in the whole makefile right here. This %. It is a variable for it's like a matching variable. So it's going to match whatever the thing is with the O. So this guy is going to be the same in all of them, but it's going to be whatever the O target was at that point. And then this is going to be the same. So it's a pattern matching. So if I said bob.o, this is going to be bob.c, bob.h, right? And this is going to be bob.c right here. And this is going to be bob.o right here, because that is whatever the target is, and this is whatever the first guy is. And these guys are all going to be the same because of this pattern matching %. Okay, so this is a recipe on how to build an object file. And so on our target, now we don't need this. We don't need to build this here. We can say our prerequisite, and this is going to expand into the objects. Oh, we haven't made the objects yet. Okay, so let's back up for a second. This is how to build an object, basically, but we need to know what our objects are that we need to build. So here's our objects. OBJS, we'll call them. What we need is our objects are going to be basically the same as the C files, right? So we just need to find what are the name of the C files. So let's find first the name of all the C files. So the C files, we're going to use something that's a wildcard. And this is, again, is part of the GNU make, not the POSIX make. So this is a function that's part of the make system. And what it's going to do is it's going to make a expanded list of anything that matches with the wildcard in it. So all of our C files are in the source directory, right? So let's do that, source directory. Okay. And they're all called something that ends with C. Yeah. So this wildcard takes this, and it's going to, this wildcard is going to say, okay, I'm going to see everything that has this asterisk in it that's a wildcard, and I'm going to expand out a list of all those things, and they're going to be space separated list of everything that is in the source file that ends with a .c. So that is a function that's taking this in and doing this. So that's going to give us a list of all the source files that we want. So our object files are literally all the source files, but with the .o instead of .c. So we could do something like this. We can use another function that is kind of a replacement, a pattern replacement. So we're going to call the sources from up here, right? And we're going to say this is a like for everything in the sources, it's going to do a pattern replacement operation. So we have the sources, we'll put a colon here, and there's no spaces in this. Don't make sure you don't put any spaces. These functions up here, they need a space after them. They're a function. This one is a pattern replacement thing. So we're going to say anything that's got a .c in it, that's in sources, anything that was expanded out in the sources that has a .c, we're going to switch it to a .o. Okay, so this is going to take our whole list of the list that we get out of here, that were all everything that was in the source directory with .c, and it's going to change it to .o. But we have a slight problem with this. The sources is in a subdirectory called sources, and our objects need to be in, they're going to be built in the build directory. So what will happen is we're going to find that the build directory will need a folder inside of it called sources, because basically the say main.c in this list is actually going to be source / main.c, and what we need is it to be in build / main.c, not source. So we can strip the directory off of this. So to strip the directory off of this is another function. And it's just going to be no, oh, sorry, not dir. So that strips it off. Okay, so now this is going to be just the object files with no directory. But we need a directory on there. We need our build directory on there. So what we're going to do now is we're going to add the build directory with another function. Yay. This is all going to make sense later. You're going to see it's going to work nicely. So we're going to say add prefix. So we're adding a prefix to this, and the prefix is going to be the build directory. And this is a comma separated, and we're going to put a / and we're going to put a comma there. So this is a function that takes two arguments. The first one is the build directory with the / and then the second one is all those things. And it's going to make now us a list of all the object files, but it's going to be .build / main.o. And for all three of them, it's going to be just like that. So this is all of our objects, okay? So we have all of our sources now. We have all of our objects. So when we go to the target, when we go to our target, sorry, where is it? Target down here. What we need to do is say for our prerequisite, we need to build the objects. Okay. Now objects are a .o file. So when this thing comes up with this this .o file, this build direct for the build directory, when it sees this pattern right here, it's going to invoke this build. So if it sees build directory / main.o, it's going to say, oh, I know what that is. That matches this guy. but the main part is going to turn into this %sign. And so main will fill up here, which is in source's main and source's main header, right? So that kind of, hopefully that makes a little bit of sense. So this is saying I need, before I build the target, I need all of these built ahead of time. And it's going to go up and it's going to expand this object thing. This is going to be a list of all of the objects we need, which is going to be 3 of them. And it's going to go through and it's going to build each one. And if the source or header file is changed for any of those objects, it's going to rebuild the object. If the source and header file hasn't changed since the last time the object was built, it's not going to rebuild it. Okay, so the target's going to say build all those. And now since we have all those built, what we need to do is just combine those objects into a binary and link it, right? So our recipe down here is going to look different now. We are going to be doing the LD flags and the LD libs down here, which we don't have LD flags yet. We still got the output, the O output. So we don't need these. We're not building those anymore. So we're still doing GCC, but we're going to do the caret, the $caret. And the reason why, this is a variable that expands to all prerequisites. So our prerequisites is actually, this expands to a list. For us, it'll be 3, a list of 3 object prerequisites. So those 3 objects are going to be placed here, if that makes sense. So this is going to say, hey, GCC build .build / main.o, or not build it, it's going to take those, all 3 of them, and it's going to say output the target, which is yellow snow. And here is the linker information that we need with the SDL. That's all going to be expanded out into the linker section. So that is going to be pretty interesting. Let's see if that works. Okay, let's go make clean. Okay, for make clean, see how these object files were populated in our build folder? For make clean, we need to manually delete these for one. We made those manually earlier, but we need to tell this folder to be deleted as well. So over here in clean, we can tell it our build directory too. That is going to take care of that. That's not going to fix the other ones. We have to manually delete those. So okay, so those are gone. Now for these we'll use the make file. Cannot remove is a directory. Okay. Because we need -r for recursive. We can just put it here. There we go. So now we have that cleaning. Let's do a build. Okay, let's do a build again. And it's all up to date. Now let's go change this. I hate it when I do that. Right, hold on. Let's restart. let's change this and put the not this, the main one maybe. Let's just put a little hello in here and see if it rebuilds that one thing and then the final binary. Hello. Okay. Okay, so I'm just going to run make, and it should only rebuild game.o, that single one, and yellow snow binary. Okay, there we go. See how it was much shorter than it was before? We closed it before, but it's only one of them. It's only building, where is it? main. It's building main.o, and then it's taking all of the object files and rebuilding Yellow Snow. So I'll show you. So that chunk is only 4 lines long, basically. And if we do the make clean and then make, it's going to build all of them. See, it's three times as long now. So, and that's going to be the same for the header file too. But the header file will only go so far as it rebuilding the object file that is the same name as the header file. So unfortunately, if you have source files that depend on a header file that are not of the same name, and you change that header file, it will not rebuild the other source file that depends on the header file without the same name. It's not that smart of a build script. So let's go back into our make file. Okay, so this is well and good. We're getting pretty far with this. We can take a look at how to make this possibly work on Windows. Again, I'm not on Windows, but we can add some stuff in. Also, we're gonna make the compiler a little bit more strict. So we have our target, we have our build directory, we have our source directory, we have our GCC with a question mark. We can also put the C flags with a question mark as well. If somebody wants to change this allows somebody else to put in their own. If they don't want to use the one we have real quick, they don't have to go in and edit the make file. They can just do that. We'll do it with the libs too. And yeah. And we're also going to just throw in LD flags, even though I'm not using any LD flags. I'm going to put them in there with a question mark so anybody can just I'm just going to put them just so anybody needs to use any, they can just, without modifying the file, they can just pass it in. Okay, so that's interesting. We got all that. So we got to, basically we got to deal with putting in more strict rules and making it work in Windows. So Windows, basically some of the things that we're going to put restrictions are not compatible with Windows. They're kind of a Linux only thing or Unix only. They might work on OS X. And also the way that the clean works, I don't think the RM works in Windows. I think we need to use Windows commands to clean things. So I'm not sure exactly how functional we're going to get with Windows, but we'll give it a go. We'll try. So we're going to do this kind of like an if else, but make file way. And again, this is a part of the GNU make. And we're going to say so if the OS is Windows, okay, and then we should be able to go else, and then we'll say and if. So this kind of setup should work to basically say, let's set some rules specifically if you're running Windows and if you're not. So the so for the Windows, the first thing we can do is fix the clean that we got going on. We've put clean down. Where is it? Where is clean at? Oh, we didn't make one. Okay. So we can say clean. Let's tab it in a bit and say well equals, and we'll just where's the clean at down here? I was after this guy right here. There we go. Not this guy. Okay, for the Windows side, we can use del, and we can use /f, and then we're going to delete the target. and it's .exe, I think. Also, we need to check if it exists. We need to delete the build directory, but there's no way we can do it without this if symbol. If we just try to delete it, we'll always get this kind of error message if it doesn't exist. So that's why it's in this if statement. We'll say if that exists, we're going to remove dir ss q, then the build directory. So that hopefully works in Windows. I think I may have tried it one time. Can't remember last time I was in Windows. So that's going to be that, and then we can just run clean down here. So we can run that for that, and that's going to give us our two separate cleans. Let's talk about C flags. So we have normal C flags here, but I actually want to make them much more complicated. So I'm going to do something called C flags dev. This is like for development. We'll bring this in. And I just want to put in a whole bunch of strict stuff. And then the release version will not need all this stuff going on. So I don't want it optimized. So it's, I think -0 and then 0. Yeah. And I want debugging symbols. So I'm going to say GG DB3. I want all the warnings on. I want the extra warnings on. I want all warnings as errors. That means if we get any warning at all, it's going to fail the compiling. It's going to be an error. I want pedantic mode, which is like stricter as well. And then all these kind of separate ones. Warn about writing string. Version. I'm going to close this sidebar here. Okay, we're going to keep going with this. It's going to be lots of warnings. Warn about shadow variables. Warn about missing prototypes. Warn about missing declarations. We're going to warn about float equal. Sign compare, yeah. Undef. What about casting? Fine. Oh, sorry. To type types. Lots of. We're warning about everything, and every warning is an error. Switch default. That was what caught our default before. Was this old style definition? That's not right there. Missing include directory. Okay, so not sure if I typed all those in correctly. We're going to give it a try. I'm going to put this exact same down for, this is actually going to be different for both of them, but these parts are going to be the same. Okay. And what I'm going to do here is I'm going to have a base C flags, and then I'm going to have a release C flags. Well, let's do this first. C flags base. So I just want these. So sometimes I'm going to want these strict ones turned on, and sometimes I'm not, but I'm always going to need this turned on. So we're going to call this C flags base. And I guess we'll tab all these guys in. Okay, so we got C flags base, C flags dev. So down here, we're just going to put the two together. And the C flags base, I'm going to remove the question mark from it because it's just going to be on C flags. So down here, I'm going to say, oops, sorry, C flags. And I'm going to say question equals, and then I'm going to put the two in. I'm going to put the base and the dev. Okay, so see that now people can still overwrite the flags, but I'm always going to have the base and I'm going to have the dev. And so this is still going to operate, but it's going to be using this hardcore mode now. That's very like it's not every error that exists, but it's a lot of errors will be caught. And all those errors will be turned into warnings. So it won't warn you and keep building. It will warn you and it will not build. So you have to fix the problem with your code. And if you're compiling often, it's going to make you write really strictly well-defined code. Okay, let's try all this real quick and see if we got it all correct. Okay, got something wrong here. Write string. Did you mean write strings? I probably did mean write strings. That was pretty good that it gives me a good suggestion. Yep, it is write strings. So up here, on the first line here, that's an S, and down here, that's an S. Okay, so we see how we got this very strict, it's throwing like everything at it. And it's compiling because we caught that, we caught the bug that we had earlier. So this is pretty cool. I want to have another phony that is release. And this phony, I want it to not use all that strict stuff. So I'm going to overwrite the C flags. So up here on, where is it? So I got C flags base. I'm going to put another one and call it release. And I'm just going to put like 02 on it. So it's going to give some optimization. And this is a capital O and then a 2. And the other one, where was it? Down here, that's a capital O and a 0. So I'm going to just put O2. So down here, so I'm going to skip all these things when I want to build a release one. It's going to build a smaller binary. It's not going to have all those checks in it stuff. It's just for when we're when we're testing the code out that we need to do all that. So let's say here we can say release. And for this one, the kind of prerequisite thing I'm going to do is I'm going to override the C flags. I'm going to it's only going to happen for this release one. C flags, and I'm going to do C flags release, and then, oh, sorry, base. Well, I'll just put it in front of it. Probably doesn't really, yeah. So C flags base, C flags release. Yeah. And I haven't changed that yet. And so we can just do release. Did I spell it right? Okay. Let's see if that works. Make sure I haven't made any mistakes. So let's go clean and let's say release. Okay. See, that's much smaller. It's not like when we did the, let's say rebuild. When we do the normal one, it's running all those warnings, basically every warning I can throw at it. And when I'm running release, it's not. So when we ran release before with that spelling mistake I had in the default, it would not catch that. The release would not catch it, but the very strict one does catch it. Okay, and it'll catch lots of other stuff too. It's really good. Okay, so we want to add a little bit more stuff to the. I want to add a memory checker, and this only works in the Linux one. So up here, we're going to have libs, ld libs dev. And for this guy, I'm going to leave it empty. And for this guy, we need these sanitizer. They're in two different places. And this might actually be an add-on package that you need for GCC. I cannot remember, to be honest. But basically, after include, we're going to do -f sanitize. F sanitize address. And there is one more. F sanitize address use after scope. Use after scope. Yeah. Okay. So these two, they actually need to be added in both places. So if I just copy these, and I don't know what I just did. I must be using the wrong button to select things. Please tell me it didn't just do that. It did. Okay, well, I'm going to copy these first then. Okay. So I need these down here as well, in both places. And honestly, I cannot remember if there's a package that needs to be installed for this to work. But this doesn't work in Windows, unfortunately. And it can be a bit, like I said, a bit weird sometimes. It doesn't always work as it should work. So this might be something that you need to disable if it's not working for you. And you can just try running release or the other one. So we have these libdev, and we're going to do the same thing that we did with C flags. So we're going to go up here to all the libs. And we're going to call those base. We'll take that away. And then down here, we'll go LD libs. And we'll do the same with the let people override it. And then this one is going to be just like the others. It's going to be the LD libs dev base first, and then the libs dev. And again, we're going to be overriding this down here. The libs equals base host. Yeah, I think it's just base and then nothing else. Yeah. There's no release version in here. You might need to add one later for your code, but I don't have one. Okay, so what this is going to do is this going to add this sanitizer, which is a kind of helps find memory leaks. And we can check this out right away too. See if this works. Clean release. I'm not release, sorry. Let's just do a rebuild. Okay, and okay, and it just said hello on the way out. So let's see if we can cause a memory leak. Let's go into game, and let's not free something. Let's not free this. Let's just disable this right here. I'm just gonna run, and it should rebuild for me just what it needs to rebuild. Okay, look at that. See, we got a memory leak, and it tells us where it was. It's in source game 5. This is probably where we allocated the memory right here, which is pretty nice for it to tell us. So if we go into was it game 5? Game 5, we have the calloc. We have the calloc, but we didn't free it right here. Yeah. So if we fix that, I'm just going to make run again. It should automatically rebuild game object file and then rebuild the final binary. And then there's no memory leak. And it still says hello, so maybe we should get rid of that line right there. Okay, so you can see if we just do like silly things, it's just going to tell us no. Like, what if we just said int num, right? Int num, that's it. Cool. And is it going to let us get away with that? No, it doesn't. It doesn't even like it, because look, it's an unused variable. Okay, but what if we used it? I'm not sure actually if it complains about uninitialized variables. I hope it does, but I actually don't know. So let's find out. So let's just say percent d num So we should have garbage data in here, and hopefully it's going to tell us we can't do this, but maybe it will let us do this. I don't think it should let us. Okay, here we go. Uninitialized. Love it. So we don't have to worry about accidentally making uninitialized, right? And it doesn't even let us compile. It just says, no, you can't do this. It also will kind of like, if you're trying to, it doesn't let numbers be cast, what do you call this? Not implicitly. Like you can't, if you try to use the wrong type, if you just run normal GCC, it'll let you get away with it. But here, you need to explicitly cast it if you want to use it as a different type. You got to say, I know what I'm doing and I'm casting it to another one. So it's very strict, but it makes you write code better, and it makes it where you're not going to have random bugs that, it's going to fix a lot of random bugs. Not everything. It won't make your code perfect, but it's going to just make it a lot better. Let's get rid of that again. Okay. And let's recompile. Okay. And well, we're rebuilding and not running it. Yeah. So that is all really good. I hope that most of that made sense. This might be in slightly different order, but I wanted to walk through and talk about all these different weird little bits about make program, because basically now that you have this make program, if you build another project, you can just drop this make file into that project. As long as you're working with C files and header files with the same names, you're using a naming scheme where the C and the header files are the same names, and all your source files are in a folder called source. All you have to do is come up here to the top and choose the name of the output file you want. It's just going to go through and build all your source, all the object, and build your binary. So it's not going to work with every project in the world, but a whole bunch of these kind of small to mid-sized projects, it's just going to give you the power to drop in this make file and just build the thing that you want to build. And I apologize for you Windows people. I don't know how well this works on Windows. Maybe you should try Linux. The OS X, I don't think there should be problems, but again, I don't know about the walled gardens. You should definitely be on maybe an open source Unix system, not a closed source one. But this is pretty good, and you can make all these kind of rules yourself. You saw how I can do make clean run, make rebuild run, make whatever, if I wanted to rebuild, and it's much quicker than typing everything out. And the one thing you will have to edit when you're using this will be the libraries that you're linking. I just checked all the ones in here that we're going to need for this project and all kind of STL projects I'm using. But if you ever add anything to your project, say you need, what is it, the math library or something, then you would just add that in here and here into the package config into these two parts. And it should be okay. I'm not sure if the math library is there or not, but just as an example, or you added in some other library that you needed that was outside of the scope of the standard C libraries. This would be the place where you add them in. This would be the place where you change the name. If you're having problems with some of these, you could try disabling them. Try doing the build release first, and then try to see if something in your code is wrong, or if maybe one of these just doesn't work on your system. I noticed when I changed from GCC to CLang, maybe the W all or the W extras was slightly more specific, and it made me add a new line character to the end of every file I had, even though they were invisible new line characters and it wasn't actually a new line. It was just a return carriage at the end. I had to go through every file and add that return carriage at the end of every file to make CLang happy. But now I know it builds cleanly no matter what. But I can also tell you, like I said, let's see if I can show you what I was talking about with this the memory leak thing. It's a bit flaky. Like let's see here. in was it main H? In main H, where we do this everything. If I say video, I get this giving me problems. Let's say let's just say run, rebuild run. Okay, when I close it, I will probably get a whole bunch of not. Yep, there it goes. See all this? And it's telling me I have memory leaks, but it's not telling me where. It's like unknown module. I think this is a false positive. There's no problem in my code. I don't think there's a problem in SDL, and I don't think there's a problem in yeah. I think this is an actual just a false positive. So it's not perfect. It is flaky. But if you have it working, and you're not getting this thing, when you start building, throwing stuff on the heap, it's going to catch you if you forgot to free something, which is really nice. And I'll show, like, if you add in video or audio here, init audio, and I think this needs to be in parentheses here. So if I add SDL init audio, I believe this will no longer complain. Yeah. So like, I don't even know what that's about. But anyway, for this project, I'm just going to do everything. It's simple, and I am kind of using most of the system, so. And that should be good. Yeah. Okay, so that's a whole lot of information, but hopefully some people can get some, better understanding about makefiles out of that. I actually think they're really cool, but they are a little bit of a learning curve in the beginning, and there's a lot of these weird symbols and stuff, and this kind of pattern matching replacement stuff, and it's a little bit daunting at first. But basically, all my projects, I'm just running the same makefile. I don't need to, once it works, I can just throw it in and it's going to work. I only need to minimally change the name and whatever libraries I'm using in the project. But let me know if it works or doesn't work on Windows. I think it should work on Windows with the deleting, but I'm wondering if the run works in Windows. I'm not 100% sure, and it probably depends on what kind of setup you have. But this is all GNU make, not it's not other makes, because of the specific commands that I'm using. So that's going to be it for this video, and I hope that was helpful. I think that was a very long video again. Sorry about that. The next video is going to be probably very short. Okay, bye.